What's going on, my people? Happy Software Sundays. I'm the host, KD. And in this series, we discuss some of the latest news in the tech industry, as well as answer a few questions from our community that can help us all become better developers and make sure we going in the right direction inside of our career. So if you're new to this channel, welcome. And if you're a regular guest, thank you for being back. So let's get started. The first thing I wanted to talk about was Anthropic cracking down on some of the unauthorized Claude code access users, and how there were a few businesses that were a building their business by taking over a bug inside of Claude code. A little breakdown of it is when you use Claude code, you get an API key that would give you unlimited access to the models you were using while coding, and then you could use that same key to access the API directly, which would give you a unfiltered access to those APIs, which created like an infinite glitch for the users where they would be able to spend $20 on the Claude Code subscription and then be able to access as much AI usage as they wanted, which could be upwards of hundreds to thousands of dollars. So it was great for everyone who was able to discover and take advantage of that code and that bug while it was out there. The problem is when for Anthropic, they're hosting these models. So every request that came in that was not being filtered by their main flow that they should have been going through, those were adding more cost and more capacity, or taking up more capacity just from those extra costs without being able to charge accordingly. Over the last week, they've started cracking down on these types of glitches inside of the system. And so some of the businesses that created their entire business model around taking advantage of that glitch are and were seeing some issues with their service over the last week. So they had to find other ways to quickly be able to pivot to now be able to provide at least a similar level of service, but they can't offer that same cost and pricing model as they were doing before. It was really just a way for Anthropic to control their costs. At the AI software level, that competition is tight. You see OpenAI, Anthropic, and all the other labs that are just spending millions and billions of dollars to train their models. And then running those models represent another cost to them. And that cost has to make sense. Otherwise, the business won't work. And so that's what we're seeing. They're trying to make it make sense now to capture their profit margin a little bit more clearly. It makes me think about that the fact that the larger your product, the more likely it is for someone to try to take advantage of it. They saw that this product is great. We love the AI results. We love having that type of intelligence inside of our product. But how can I take advantage of the opportunity that I see? How can I make sure I'm getting $1,000 worth of usage without paying $1,000? You know, sometimes the incentive for the bad guys is actually the worst thing for your business. So when you're growing and improving your business, you have to keep that in mind and make sure you're building controls, you're building uh, security and monitoring so that you can identify when some of these uh, edge cases have been found and also be able to close them down as quickly as possible, depending on when and how you want to do that. I'm pretty sure that Anthropic was comfortable getting all of the users comfortable with their model, right? For the last couple of months where this glitch existed, there were regular users that were using the product, but then there were these power users that were also realizing how great the product is, even though they were taking advantage. right? But now that you've been using it for months and it's been a good product, even though they tightened the security on it, that doesn't mean, or that doesn't make it more likely for you to not use the product at all. At this point, you might be addicted to using their intelligence. So now you gotta keep it going. So just keep that in mind for when you're building new products, and how maybe this was just a way for them to create like a loss leader, like with retail, where you make something that is costing you more money to provide to your customers, but it gets enough of those customers into the door that when it's time for you to figure out how to make the numbers make sense, you already got them. So, you know, if you're building a business on top of a bug for another business, also keep that in mind. Don't get too comfortable. Your business has to comply with their terms of service. Every business for and that's providing a product or a service is going to have some type of terms that you have to comply with. If it's not yours, if you don't own it, be prepared for things to change, and you have to just make it make sense if you're going to keep using that product. Another thing that I had saw from LinkedIn was a kind of article about things that developers in the common modern era can do to stay relevant with the technology and the changes that are happening right now inside of the industry. This article was from a managing director at EY, and we used to work with him. He's a very intelligent guy who has been in the industry for decades at this point and has been doing and leading a lot of great work. But I'll just share some of the highlights that I picked up from reading his thoughts. So, one of the major things to consider if you're going to become an expert developer and if you really want to improve in your craft is you have to learn from the masters. Learning from the masters is so much easier with software because a lot of software is open source. Some of the best types of software that's most performant, that's most cleanly designed, and that does and works everywhere is open source. So you could take a look at the Kubernetes repo and see, hey, how are they building the engine to synchronize different pods or synchronize different nodes inside of a cluster. You can see exactly how those master developers made that code work. And even if you're working at a company where you have access to their code base, that's really a great time just to see kind of what mindset that developers had when they were building this software. Yes, you're maintaining it and you're seeing the parts that you need to tweak as things come up, but there was a design process that went into building the software, and that those nuggets that you can get from just going through and learning behind those people could be incredibly valuable for you. Another thing which I kind of I won't say I disagree with. It's true, but it shouldn't be the case. Is the fact that most applications don't have uh, a lot of documentation in place. I mean, you really said instructions, but it's documentation. They don't, the developers or builders of the applications don't always make it clear what this particular piece of code is supposed to do or what this application is supposed to do. They just build it out and have the logic, even though the logic may be clean and very precise. If you don't take the time to learn how to read that logic, and if you don't take the time to study what and why this is working how it is, then you may not be able to understand and get the full impact that you could get. That means you have to be very curious. You have to be willing and have enough grit to say, let me go find a project that is worth studying. And you have to be able to stay with that project for long enough because it won't make sense the first time you read it if there's no documentation or if there's no quick way to just jump in. They don't always have a start here, right? If you're doing a tutorial, it's going to say, hey, you can start with this, and then we give you some code, or they'll give you step by step instructions for how you can turn this project into a hello world app running on your computer. When we're in real projects, that may not always exist. So you have to be capable of just jumping in and being comfortable just learning as you go. And you'll definitely learn, but it'll take some time. Another thing that is probably crucial and key, especially today, with the market being how it is, and just with the state of the skill, right? There are a number of people entering the technology industry, and AI and these no code tools have made it so much easier for people with little to no experience to get started. So it becomes incredibly difficult and important for you to figure out how do you differentiate yourself from the rest of the people inside of the market. The simplest way to do that is to build a brand that people want to connect with, a brand that people feel comfortable bringing into their team, feel comfortable getting industry insights from. So you have to figure out how to curate that for yourself. And that could be focusing on one or two platforms where you're sharing your ideas or your voice. Uh, that could be making sure that your portfolios are very clean and careful, carefully curated so that when someone looks at your GitHub and says, hey, oh, this is the type of project that this person is familiar with, this is how they work, right? Maybe we can see your commit log. Maybe we can see your repo. We can see the code files themselves and whether or not you have modular functions or uh, very clean designs inside of your code. Having that available for someone, whether it's a recruiter or potential partner or even customers to look at, is going to be very helpful for you. And that's for like a very engineering specific standpoint. But if you want to just be known as someone who can have a good conversation with others, right? A lot of developers are not known for being uh, very outgoing and open. Maybe you can change that for your group. Maybe you can make sure that the people that you work with know you are a delight to work with. They know that you are willing and able to get the job done no matter the cost, right? You have the drive to move with urgency whenever it's necessary, and that's what you have to build. You have to build that look, and you want to make it incredibly easy for someone who wants to work with you to get that signal out of you. You don't want to make it difficult for them to understand how driven or how experienced and skilled you are. You want to put that out there as much as possible so when it's time for someone to pull the trigger and work with you, it's a clean shot. And another thing that is worth mentioning is the fact that your tools are going to be the difference between you moving quickly when necessary and not being able to. We have a bunch of different IDEs, we have a bunch of different languages you could use. You have the opportunity to pick one and make sure that the one you pick has been customized enough to make sure you get the most out of it. You want to make sure you're developing as quickly as you can, as accurately as you can. You want to make sure whatever tool you're using to uh, visualize your architecture, you understand how to use that as well as possible. You want to make sure, and you can share that information with anyone else on your team, right? You want to make sure that your toolkit has everything you need for you to deliver the best results to your clients and to the rest of your team. And that comes with taking the time to learn the tools. Yes, you can say you know how to use a language, or you can say you use this type of IDE. But if you're not spending time really learning the shortcuts, learning the edge cases for the technology you're using, and actually just playing around with the things that aren't as common and aren't as familiar to you or anyone else, then you won't be well prepared for the time where it's going to be incredibly necessary for you to understand those very niche use cases. I also wanted to share a little bit about the crypto space and how Wyoming has issued the first state reserve backed stablecoin. And they put that out on Solana. And that is incredibly interesting, but it's definitely in line with Wyoming and the type of innovation that we're seeing out of their government and the policies that are coming out of there. And it's also interesting to me just to think about the fact that that type of state specific law inside of the crypto space. So far, we've seen a lot of laws that are taking place from the national level, and there was still a bit of room for these states to implement their own designs for these crypto assets and the value that it brings to their citizens. So the token that has been released is on primarily on Solana, but they've also made it work on cross chain on different EVMs like Ethereum. They have it on Avalanche and a few other L2s as well to make. And I guess I haven't looked too much deeply into the why for it, but I can imagine it's a diversification play. It's the fact that we're still not sure which of these blockchains is going to last the longest, but if you have the chain or the stable coin or the tokens that you're minting on this one chain being propagated to these other chains, as long as any one of these chains exist and they aren't hacked or they aren't somehow made unavailable, then that data still exists. So it's like having a bunch of different backups on a bunch of networks that provide a bunch of different backups. It's a great way to make sure that the data never gets lost. I mentioned it a few weeks ago about the governments having the hardest time preventing hacks because they have so much information that they store that it becomes a gold mine to hackers and state sponsored hackers and those types of groups. So when we put that information onto the blockchain, it makes it more difficult for a ransom to occur or some type of cyber attack to occur and knock out the systems for that uh, population. I do think it's interesting that there is a there was a company that was put. Well, let me step back. The stable coin and the coins that were released are put inside of a trust. The trust is the beneficiaries of the trust are the students inside of Wyoming. So I expect that whatever the value of the stable coins will be into the future, if there's any type of growth or if there's any type of uh, interest that is given back to these wallet holders, they'll be able to reinvest those dividends into the education programs across the state, which makes it a social good to move your assets onto the blockchain. But it also is just interesting that it also brings another level of security and oversight because now if you're creating a state specific stablecoin, that makes it more likely for the states to provide their own funding for programs without having to go to the federal government to print those dollars for them. they can create those dollars, those coins for their citizens, for their residents, and then make those stable coins useful inside of their actual state. So you may not be able to go across state lines and use that same stable coin, but as long as you're in the state of Wyoming, you can you'll probably be able to pay for anything that you want. But with that type of accessibility, there's also that a lack of confidentiality, right? Because every purchase and transaction that happens on the blockchain is stored in public on the blockchain. So you'll, as a user, need to be able to keep in mind, hey, are you, and I don't know, it depends how your wallet is configured to make sure that you can have a private transaction. Because I think the only reason that we need uh, blockchain enabled money is so that we can have more transparency from the government. That doesn't mean that we need the government to have transparency into everything that we're doing as citizens. But once it's on the blockchain, everyone has access to it, so it's fair game. Just keep that in mind as similar programs begin to roll out across different states and countries. Um, the legacy banking infrastructure was not as automated and connected as these blockchain networks are going to be. So that privacy is kind of blurring the lines at this point. And that was pretty much all we had for this week and different interesting news. Definitely look into some of these programs and the things that are changing and make sure you're understanding how the landscape is being affected with every one of these changes. We're right, you're seeing different uh, pricing models happening inside of the market with Anthropic and the different AI model providers. How will that change development into the future? If we're seeing different tools becoming available, what does it mean to be an expert now inside of the technology space? If we're thinking about the expansion of blockchains across society, what does that mean for privacy and the future of money? These things are all being changed now because of these impacts and these stories. So definitely look into it. Uh, reach out if you have any questions or if you want to just discuss kind of what's going on because this is the world that you live in. You should know everything possible about it.
What are about 5 commands you use on a daily basis?
So for me, I spend a lot of my time, or so far, just building software. So I'm running my code. I am testing the code, and making changes and keeping changes inside of Git and as my source code repo. So I use Git from the command line very heavily. I am committing changes. I am checking the logs, see what has gone in. I am changing and creating new branches throughout the day. So Git is one of my, I would not even say one of mine. That is my top command that I'm using every day. And it's very useful, right? As a source control management tool. If you're going to be a developer, whether you're using AI tools or well, you should be using AI tools, but however you develop, you're going to use Git. So become familiar with GitHub, with Git, like the actual CLI command line tool. Understand what a branch is. Understand how to do a merge, how to rebase changes, how to push your changes to your remote branches. You gotta have Git inside of your toolkit because you can't really do much without it. Next, I'm always using an ls and a cd. Uh, both of these commands are going to allow you to navigate your code bases or your file systems very quickly and helps you identify any types of files or folders that were not visible when you were using your Finder or your regular file application. Definitely understand these tools, understand the options that are available so you can see hidden files or so you can uh, move between directories much faster than what you could have by just clicking around. And another thing I use is aliases. And I gotta mention it because I'm not using the alias command every day, but I am using aliases that I've created using the alias command. So that pretty much just means I, instead of putting git push into my uh, terminal, I'm going to use GP because I've set up an alias that can allow me to more quickly make some of the commands that I would have made anyway. It just makes it allows you to customize your space to work for you a lot better and allows you to move faster, right? Because instead of typing those 8 characters, you can type two now. And it's like giving yourself a way to build a language and build automations that you can use to make your day easier as a developer. So, because run who wants to run everything all the time? You got to have some type of aliases in place to make sure you can do it a little bit faster because you're going to be doing it all day. You don't want to keep writing get push, get push, get push. GP, that is do it. If you're doing it a little bit more uh, common than that, you might even just put one character as an alias. Although I wouldn't recommend it for some use cases. kubectl, that is a command that I've used not so much recently because I haven't been working with Kubernetes in a few weeks. But when I am working on a KH project, that's what you're using. That is how you are authenticating with your clusters. That's how you're going to check up on the status of pods. That's how you're going to get into your pods. Uh, you have to understand the kubectl if you're going to be working with Kubernetes, and you probably should be working with Kubernetes. So familiarize yourself with that tool. And this is just 5 that I use more commonly. I definitely want to get better and learn more about Linux because that's what we're talking about. Right? We're talking about Linux commands because they allow you to do some pretty interesting things. They allow you to build powerful scripts that can allow you to automate deployments. You can automate testing. There are a bunch of things you can do through a bash script, and being familiar with some of those commands will allow you to just do it much more easily.
Also, how long does it usually take to build an app?
It depends. It really does depend. But it really will depend, one, on the type of app that you're building, and we'll get into that a little bit later. But if you're building something that's going to have 1 or 2 workflows where the user is just going to do one, two, three, uh, that can be done by a developer moving really quickly in about 2 to 3 weeks, especially if it's going to be like a simple CRUD app. You can get that done pretty quickly if the developer is moving as fast as they can be. If you're trying to add any types of production readiness to it, where you're trying to not just build the app, but you want to make the app available on the cloud, or you want to make it, you know, productize it so that other people can use it, and that you have like CI/CD pipelines in place. You have some type of monitoring in place. You have uh, accurately and clearly documented some of the processes that you have been doing. That might take you a little bit closer to 3 months because you want to make sure that everything is aligned the way you expect it to be aligned. Then, if you're thinking about something really large that is in a specific domain, like anything inside of healthcare or inside of the financial sector, because you're dealing now with PII and PCI. Those types of projects are going to take a little bit more time. You may need to integrate with more systems than you would for a simple CRUD app. And so that may require you to take up to 6 months or maybe even longer to develop that app and release it uh, to whatever environment that you want it to be released to. And it's really just you're spending a lot of the time not writing the code. The code is actually some of the easiest things you can get done, especially with AI and all of the other tools that are available. The challenge is going to be designing that software. If you go into any type of build without having a plan for what you need to build, why it's being built, and what it needs to do, you're going to fumble every time. And so assume that at least 70% of the work is going to be done quickly. That's going to be just setting up the screen. That's going to be just setting up the initial flow. But that last 30% is going to be you adding tests and running those tests to make sure that they work reliably every time. That then is going to include you adding some type of security concerns, like how are you handling secrets inside of your application? Are you just hard coding things? That's not going to make that app operationally safe. It's going to be very difficult to change and deploy into different environments as needed, or to replace keys that get leaked, which it may happen. So a lot of that design is going to take most of your time, but in that 30% is going to be the most important part to really take your time with. You don't want to rush through it. And if you want to build fast, it doesn't just mean just adding more developers into the kitchen, right? You don't, if you want to build, I say build, if you want to cook a turkey faster, you don't bring in 3 chefs. You can't build it, you can't cook it faster. So think about that when you're building an app. If you're looking to just build something quickly, then you can just put whatever you need to get it to work, to get it to look like it works. You don't even need to do too much coding development in there anyway. You're just validating something. But if you want to get something in place into the market that can handle payments securely, that can manage and allow users to onboard, and if you want to have these other integrations with different systems, then it's going to take more time because you have to make sure you're understanding exactly where to put these different components so that everything is working over time and is maintainable.
What's the difference between a web app and a regular website?
So a website is going to be filled with a lot of static content. That's going to be like a menu. That's going to be some information that doesn't change very often. It might just show the prices for your, maybe not on an e-commerce website, but a simple website where you're just sharing this is how much a service costs per hour, or you're sharing like photos and videos. That type of static content is going to be a website. There's not too much going on in there. You can cache that data and it can be available anywhere very quickly. Uh, this is for an app, or this is for a project that is going to be primarily reading based. You're just reading and looking at things that aren't changing very often. If we're talking about a web app now, this is going to involve more dynamic data. This is going to involve more stateful data sources. So you're not having some piece of content that's just always there. It's being constantly updated in the background inside of a database, and that's being pulled every time that website loads. That's going to be more task driven, where your web app enables a user to do something, either update some data inside of a database or their inventory. That could be allowing them to message a customer that is reaching out to them so they can, have some processes and automations in place to email or call people. So you're doing a bit more when we're talking about web apps, because now it's not just some data that's coming to you that you're just reading as it comes. You're trying to write now, you're trying to do a little bit more with other resources that may or may not be visible inside of this interface that you're looking at. That web app is also going to include things like authentication for every request or even just for a session to make sure that the right person is accessing the data, because we're talking about dynamic content, right? We want to make sure that the person who is looking at this data source or this database is the right person that needs to be seeing it, and that they see the right thing that they need to see, not any more or less than what they need to see. So that's the main difference between a web app and a website. It's really just about when will it be best to use one of these products. A website is maybe more externally facing, whereas a web app may be more internal, where you want to make sure that your people can do whatever they can do with that app.
When should I be using solid design principles in the app?
So, solid design principles help you make sure that your app is maintainable, testable, and can scale without breaking over time. So, you're going to use solid when you're confident in what you're building is going to be around for the next 12 to 24 months. You're going to use solid when you are expecting to have multiple integrations and multiple types of tools onto your platform. You're going to use solid when you're working with a team that needs to work together to build different components of that application. Solid is a very, it adds more complexity into the product that you're building, because it's not just, hey, let me get this screen to work, let me get this function to work. Now we're talking about, how do I get this function to work today, but also be extensible enough that when I need to replace my Mongo database with a Postgres database, the business logic still works exactly the way it was supposed to work. Uh, it means, how do we make sure that this app that could run on one environment, maybe in AWS, can also work on prem? It's all about thinking about the next step forward. So you don't have to worry about solid if you're just building a throwaway app. If you're just building something that you want to just test, right? You want to get a little bit of feedback before you want to invest too deeply into it, then you'll just build something. You can skip all of the design, skip all of uh, the formalities of the solid requirements and the interfaces and all of the things that you have to do for a solid app. You can jump straight past that and just build what you need to build and let it work. But if you're confident that this app is supposed to do this and it has this functionality and it will work for these people and at these times, then you want to think a little bit more about, how do we make this a solid app? How do we organize our directories and our folders and our modules so that anything can be switched out as needed and still uh, keep the same level of accessibility for that app? Use solid when the cost of change is high. So you want to make it easy. And then that way, as your product grows, you can always mix and match things, because all of the connections are in place for a AWS email service provider to be replaced with a Firebase email service provider, or a IDP, whatever it may be, whatever that integration may be that you're using. Solid allows you to replace them easily without heavily impacting the rest of the uh, features on side of your product. So Think about that when you're having integrations with SMS, maps, identity providers. It's all that type of thing requires you to really think very deeply about, right, what is this app going to do and need to do moving forward? Because your roadmap is going to decide what changes over time. If you don't have that roadmap, then you may not need to even think about changes over time. You just need to get something working today. But that's only the start. That's not going to get you to the scalable app that can support billions of users or process billions inside of transactions or even work at all times in all regions the same way. You got to use solid when you're thinking about those types of scales in your application or product.
And lastly, what's the best way to debug issues in my code?
Make sure you can reproduce the issue reliably. The worst thing you can do is be trying to solve a problem and not be able to get that problem to start, right? You want to make sure that you understand exactly what types of input causes the problem, whether it's a string or a number or a value, whatever that value is or the setting is that makes your app screen, have that clear before you even start touching anything in the code. Because think about it. If you try to change something without knowing how to reproduce the issue, how will you ever know that it's even fixed? So start there. Even if it's just the environment that it breaks in. Does it only break in develop? Does it break locally? Does it break in production? Like, understand where is the line for this happens when this happens, right? And then think about shrinking your surface area. A lot of us are building and maintaining distributed systems. Distributed systems mean you're going to be touching a dozen different technologies through the runtime of your app. You don't want to have to touch and test a dozen different platforms just to know whether or not this data is accurate or not. You need to be able to say, okay, this is where that data is coming from. Let me go check there. Or this is where the error is coming from. Let me check that module. You have to be able to cut away the places where the app or the error is not going to be. If you can do that reliably, you're golden. If you can't, you're going to be searching for a needle in a barn full of needles. It's going to be hard. So make sure you understand how to kind of isolate the problem in whatever system that it is. And then you want to make sure you're observing the actual problem. That means checking the variables and logging the outputs and actually comparing the actual output to your expected output. You don't want to guess your way through a troubleshooting session. You have to make sure you are documenting as you're going. Hey, this is what I expected to happen. This is what happened. This is why. You could even say this is why I think it happened. And as you're getting new ideas for what to fix or what to improve, you can start making those changes as needed. You want to carefully review any type of errors, right? You might get a stack trace that includes 5 different files. Make sure you can clearly identify which file was the main source of the error. And then you want to look inside of your database logs to understand that this is where the data looks like here. This is what it looks like over here. You have to be able to observe exactly what you're seeing. So when you're troubleshooting, do your best. I know it's sometimes hard. I know it's sometimes hard to get the access that you need, but you have to at least ask for the permissions if you're working on a team for all of the systems that are going to be in scope. If it's not in scope, then you can't test it, right? So make sure you have the permission and the accessibility to observe the actual system that you're uh, checking. And ideally, you can run all of this locally and still be able to reproduce that error. And then finally, you gotta use the right tool for the layer that you're currently debugging. Imagine that you have all the right access to anything that you need to see inside of this distributed system. And you know how to reproduce the issue in whatever environment that it is. And you know and are seeing the right logs or variables as they change between the different layers of your app. Now you have to make sure that you are using the right tool to test that right layer. If you know the issue is coming from the API or you think it's coming from this specific API, use curl or postman to test that API and then try to validate what the issue is coming from there, right? Then when you're getting a little deeper, like, all right, I know it's this endpoint that's causing the issue or this API that's causing the issue. Let me dig into the unit test for that handler or that controller and that service layer. You want to go in stepwise to make sure that at every layer you are using the right tool to test the data for that specific layer. That could be using a debugger to and adding breakpoints throughout the code to make sure you understand how data is changing between different levels in your system. That could mean if you're seeing everything being accurate inside of the application layer, like all the data makes sense, the transformations make sense, but you're just not seeing the right results when you pull that same data. Maybe go check the database. Maybe there's something inside of the database table or schema that is causing the issue. You may need to go there. And there are different tools for checking the performance of a database query or the performance of the network that you're using. You have to make sure that you're not just using the tool that you have. You have to make sure you're using the tool that's going to work for what you're working with. And again, started with that. Learn all of these tools that you're using. Learn them better than anyone else. That's pretty much all we had for this week. Uh, Again, like, comment, subscribe, all that YouTubey stuff. I really want to understand, what you guys need to learn and what you're interested in and what you want to discuss. And so please leave a comment. Let me know what's on your mind. What could I have been more clear on? What am I missing or not getting right in your opinion? We could discuss that as developers. And before we get out of here, I wanted to say and give this message to anyone who needs to hear it that you need to believe in yourself. And I know you already know you need to believe in yourself, but I want you to choose to radically believe in yourself. Whatever it is that you have on your mind for what you want to do and what you know you will do, believe in yourself before anyone else believes in you. Believing in yourself, I mentioned it before, it means investing in yourself. Uh, but that also means doing it before anyone else is proving to you that it's worth believing in. So it's going to take a lot of time and energy to just show, yo, I know what I'm talking about. I know what I'm doing. You got to just start doing it. They're not going to clap or applause when you're talking about it, designing it, and thinking about it. But someone, and you're not doing it for applause, you're not doing it for all that, but you're going to get all of the applause that you were looking for before you started after you start if you just decide to believe in yourself and start. Uh, you got to believe in your ability to solve the problem no matter how difficult it'll be and no matter how long it takes. You have to know in your heart of hearts that you are the best solution for the problem that you're trying to solve, that you are the best person to compete in that field. We are all developers, right? We are all builders, building the future of our world. That's what technology is at this point. We're creating the building blocks of the future system, whether it's the economy, whether it's the transportation system, the education system, all of that. We are currently building that out. And a lot of that is going to live on software. So believe in that vision that you have for the future and believe that you are the person that can bring that into reality. Because you are, if you choose to believe that you are. So with that being said, I hope that was uplifting to you. And I hope that y'all see how much I believe in myself and that we all choose to believe in ourselves and each other. So with that, peace out, be great, and see you next week.